Welcome, welcome, welcome. So in this video we will learn all about the salt in and salt out method. So what do you mean by salt in? That lower concentration of the salt makes the protein in, that is dissolve it, whereas higher concentration of the salt precipitates the protein, that is makes the protein out, that is precipitates the protein. And how it is happening, that we will see. Again repeating, that salting in, that lower concentration of the salt makes the protein in, that is dissolve it, whereas higher concentration of the salt makes the protein out, that is precipitate it. So this figure is showing the salting in method. Salting in, this is salt in and this is salt out. This diagram is showing about the salt out. So how it is happening? So if we draw a graph between the salt concentration on x-axis and solubility on y-axis, we will see that at very initial salt concentration, we have just started the process. We can say that there is small solubility is very less. So here we can see that there is solubility is very less, and only solubility is by the hydrate cell. So since we have water molecules, hydrate cell is formation is there. So here it is written also hydrate cell. So this hydrate cell which has formed around the protein molecules, because the hydrogen bonding between the water and protein molecules, this has maintained the slight solubility of the protein molecules, and then and also protein molecules have just, they can stick to each other but not get aggregated, meaning that hydrate cell are providing a slight stability to the protein molecules. Here solubility will be less, and here also we can see that the salt molecules are not in very high, means not in sufficient quantity to shield the protein molecules against aggregation. Now aggregation among the protein molecules can be by a different interaction. It can be hydrophobic, ionic bond, disulfide bond, then there can be hydrogen bonding always, then there will be always van der Waals forces. So by all these interaction, the protein aggregation may happen, but at very low concentration of salt, there are not sufficient salt ions to shield the protein molecules against precipitating. So they may come towards each other, and because of the hydrate cell only, there will be slight solubility will be there. But when we are increasing the salt concentration, that is to a medium salt concentration, we say that at low concentration, this very low, at very low concentration, this is at low concentration. At low concentration, what will happen? These salt molecules will shield the protein molecules against aggregation, that is they are adhering to onto the surface of the protein molecules like this. Here we can see that the salt molecules are adhering onto the protein molecules and preventing the aggregation of the protein molecules by different interactions like hydrophobic, ionic, disulfide, hydrogen or van der Waals forces, and thereby dissolving increasing the solubility. So lower concentration of the salt makes the protein in, that is dissolve it. And what happens at high salt? So if we have very high salt concentration, we can see that the diagram is shown here. So what will happen? There will happen competition between the salt molecules and the protein molecules for the water, and all the water molecules will be taken up the salt molecules. So water won't be available for the protein molecules to dissolve, and thereby protein molecules will get precipitated from the solution by different aggregation, different interaction which will be taking place, like hydrophobic, ionic, disulfide, hydrogen and van der Waals interaction which will be taking place, and the protein will get precipitated. So this is the basic concept of salting in and salting out, and this phenomenon is used to purify and concentrate the desired proteins in a solution. Say if you want to fractionate different fractions of proteins or caseins in milk, we can go salting out method that we will see in the coming slides. Okay, now let us see in this concept one by one. So solubility of a protein at low concentration, low ion concentration. So a low ion concentration increasing as the salt is added, is phenomenon known as salting in. So this phenomenon is showing the salting in. So it's showing that at very low at low concentration of the salt, the solubility of the protein increases. Why? Because additional ions seal the protein multiple ionic charges, thereby weakening the attractive forces between the individual protein molecules. So what are those attractive forces? These all forces, the hydrophobic, ionic, disulfide, hydrogen van der Waals forces will be there. So since they are shielding the protein molecules against aggregation, so solubility will increase. Now as more salt is added, particularly with sulfate salt, the solubility of protein again decreases. That is the salting out phenomenon. So this is salting out phenomenon. Why it is happening? Because this salting out effect is primarily a result of the competition between the added salt ions and other dissolved solutes protein molecules, that is for the molecules of water. So that is mean to say that if a higher concentration of the salt will be there, then your salt molecules and protein molecules will compete between themselves for the protein of the water molecules, and all the water molecules will be taken up by the salt and leaving the protein for aggregation, because protein that water won't be available for the protein molecules to dissolve it, hence they will be getting precipitated. So at very high salt concentration, so many added ions are solvated that there is significantly less bulk solvent available to dissolve other substances including proteins. Okay, now since proteins precipitate at different salt concentration, and that each and every protein have specific solubility, that at a particular salt concentration definite protein can be precipitated, and using this property we can purify the protein, we can concentrate it target protein. Let us see that how it happens. So since proteins precipitate at different salt concentrations, salting out is the basis of one of the most commonly used protein purification procedure. One of the most commonly used protein purification procedure is the salting out method. Adjusting the salt concentration in a solution containing a mixture of proteins to just below the precipitating protein to be purified eliminates many unwanted proteins from the solution. Say we know that say this is a test, and this is a tube, centrifuge tube, and we have different type of proteins in the solution. So here we can see the blue color, green color, and then pink color. So if we want to isolate the target protein, or if we want to purify or concentrate the target protein which is blue in color, how we will proceed? So first what we will do, we will add the salt ion concentration, and the salt ion to be added at a level till unwanted proteins like pink color proteins will get precipitated. So here we can see that we have added sufficient salt concentration which is sufficient to cause the pink color proteins to get precipitated. These are unwanted, we want blue color proteins. So what we will do after precipitation, we will centrifuge it, and this protein will get settled down, and then the supernatant will be taken in another test tube. So again salt concentration for the target protein, say target protein is precipitating at particular salt concentration, and that salt concentration will be used to precipitate the blue color targeted protein molecules, and then again centrifugation will be done, the supernatant will be removed, and then water will be added to dissolve the protein, and in turn we will have the protein solution containing protein of the desired protein which has been purified and concentrated. So this way we are purifying a particular protein from a mixture of proteins in a solution. This purification and concentration happening during the salting out process. Okay, so this way we can also, as told you, that we can fractionate different fractions, that different whey protein fractions like alpha lactoglobulin, beta lactoglobulin, serine proteins. We will be able to isolate, we purify, fractionate these proteins, or the among casein also, say alpha casein, alpha 2 casein, kappa casein, gamma casein. If you want to fractionate all these type of caseins also, then phenomenon salting out can be used. Okay, then after removing the precipitated proteins by filtration or centrifugation, the salt concentration of the remaining solution is increased to precipitate the desired protein. So we are targeting the next protein, which is blue color protein, and we will increase the salt concentration, and we know at particular salt concentration that protein molecule will get precipitated, and then we will be centrifuging it. The precipitation of the desired protein is then dissolved in water to make solution of this protein. So the precipitated protein will be dissolved in water to have its solution, and this procedure results in significant purification and concentration of large quantities of protein. So as I told you, that is the most common method for the protein purification and concentration. Now most of the times for salting out phenomenon we are making use of ammonium sulfate. Now question is, why ammonium sulfate is used for the salting out method? or is preferred for the salting out method. The reason are three. First, that it is having large solubility in water. Second, it is its relative freedom from the temperature effects, that is not affected by the that much from the temperature as compared to the other salts, and it is not causing any harm to the proteins, that is not denaturing the proteins to that extent. So that is why, because of these three reasons, that ammonium sulfate is being preferred for the salting out phenomenon to purify and concentrate proteins from a mixture of proteins in a solution.